challenges we've faced have been things that we would never anticipate, things that would never crop up on a P set. How are we going to get materials to site? What are we going to do when this starts to break? Our formwork worked in theory. Why is it exploding now in the middle of a concrete pour? Problems like that, it teaches us really to anticipate all the possible things that could go wrong.
I was standing outside. I wanted to ensure that we were indeed getting like 6 to 8 meters per second because that's what we calculated. And all of a sudden I heard pshh, and no water coming out of the tail race. And I quickly turned off the ball valve. Luckily the pipe didn't explode and the water shot over there under the wall. And it looks like we have a pretty strong wall. Luckily, we let the plaster set for a couple of days before testing this, or else you would see either brick or have a hole in the wall. So what it did is it shot this right off up here and here. And so now we're figuring out our next steps. Another day on the site.
So, Kevin,
yes.
Why are we on the road from Butare to Chibeho on today, July 21st?
Well, our second generator broke, so...
How did it break?
Well, it exploded, to be honest.
We had some issues with the Ryobi charger. Well, the first time that we tried plugging in, it actually smoked. The second time we plugged it in, it caught fire. So it's kind of dead by now.
Kevin, why am I always interviewing you when something blows up?
I honestly don't know. It's not my fault. I promise.
So we're at the site right now. I'm standing at the far edge of the kiosk where the penstock is going to come in. We had assumed that we could bend the PVC pipe to do what we wanted to, which was working great until we noticed that we were bending it so much that some of our connections were starting to pop. PVC glue is different here than it is in the US. And so we're at the issue of having one 135-degree connector right here. Plan was to just bring it down, connect it up, send it right into the kiosk. We thought that would work great, but we're finding the issue that our angles just don't work out. So we're trying to get creative, figure out whether we could either bring it into the kiosk at an angle and have the turbines at an angle, which might be kind of ugly, but might work. Or the other option would be trying to move this whole section of pipe, so that's 18 meters of pipe, and move that farther down the hillside, which would require carving out a lot more of a trench, potentially. So those are the design decisions we're faced with today, as well as we started digging the tail race, which we thought looked great, but Adam pointed out that that's kind of our kiosk foundation that you can see over the edge, and it's supposed to be supported by soil, and now it's not really supported a whole lot anymore. So we're going to run that by the team at Equinox, run it by a couple of other geotechnical engineers, and make sure that it's okay to have the tail race right here. Otherwise, more design thinking. This is another day on the site with Dartmouth Humanitarian Engineering and Equinox.